Okay, so today's lesson, which is section 9.5, is going to be over properties of logarithmic functions. And what we're going to be doing in section 9.5 is converting from logarithms of products, powers, and quotients to expressions and vice versa. And then we're going to simplify expressions of logarithms. Okay, so first of all, let's talk about your properties. There's three main properties of logarithms. The first one is the product rule. And with the product rule, it's going to show you how to rewrite the log of a product. Okay, so the product rule says if you have a log with a base doesn't matter, and you're multiplying, you can expand your logarithms out with addition. Okay, so let's take a moment before we go any further and let's talk about our rules for exponents. So when we are multiplying expressions that have exponents, for example, if I gave you 4x to the third times 8x to the sixth. Okay, what's our rule here? When we multiply our constant. So 4 times 8 is 32. And then what do we do with exponents? We add, exactly. So we say 3 plus 6 is, and we get x to the 9th, right? What do we do when we divide? So if I gave you 4x to the third over 8x to the 6th, what do we do there? We divide the numbers, right? And subtract, exactly. So 4 divided by 8 is 1/2, correct? And then we subtract. So 3 minus 6 is -3, right? Okay, y'all with me? Mac, you good? Okay, so I want you to think about, and then of course we will move this to the bottom. So it'll be 1 over 2x to the third. But I want you to think about those two rules. So when we multiply, we add exponents, and when we divide, we subtract the exponents, okay? Let's go back over here. So again, that first property says that if we have a log with a base and the expressions are being multiplied, we can expand them out with addition, okay? And that's related to your properties of exponents, because properties of exponents says, remember, if we multiply, we add exponents, okay? The quotient rule pretty much says that if we have division of expressions, then we can expand it out into subtraction, okay? And then our last property is the power rule property. And the power rule simply says if we have a log with a base and we have an exponent with that expression, we can move it to the front. And so it becomes P log base A of M. Okay. All right. So when we think about using these properties, just keep in mind that you can use these properties on the left side or the right side, okay? So let's just look at a couple of more properties, and then we're just going to jump into some examples. So a base to the logarithmic power. This simply says if I have a base, if my two bases are the same, then my answer is what I'm taking the log of, okay? And that's kind of small, so I'm going to rewrite it over here. So I have a to the exponent of log base a of x. So my base here is a. Remember, your base is that big number that you raise to that exponent. And then my base of my log is a. So because my bases are the same, my answer is what I was taking the log of. So that's x. Okay, and then I skip this one. So essentially it says the same thing here. If my bases are the same, so I have log base a of a to the x. So my two bases are the same, then that means my answer is x. I can simplify that. Okay. Question so far? All right, so let's look at example 1. So example 1 says to express All right, so example 1 says to express as the sum of logarithms. So our first example, we see log base 4 of 64 times 4. So if we're expanding using our sum of logarithms, that simply means when we see multiplication, we expand it out to addition. So this becomes log base 4, and you're giving each thing that you're expanding out a log. So log base 4 of 64 plus log base 4 of 4. That's what it says. Okay. Again, we saw multiplication, so that means we can expand it out with addition, and each thing gets its own log. So B, the natural log of AB, again, we have a log, and then A and B are being multiplied. So we can expand that out into the natural log of A plus the natural log of B. Questions there? We okay? Okay. Let's move on to example 2. So example 2 says express as a difference. Okay, so let's think about that rule again. It says if we see division, then we can expand it out with subtraction. So I have the log base A of 76 over 13. That means I can expand that out, give each thing its own log. Log base A of 76 minus log base A of 13. Okay. All right, what about B? We have a log and we see division. So how can that be expanded out? Take our natural log. So we have the natural log of X minus the natural log of Y. Questions? You okay, guys? All right, so moving on. Example 3. Express in terms of sums and differences of logarithms. So again, we're using our properties, but you'll see that we have more than one. And so we'll have to use them all, okay? All right, so the first thing I want you to recognize is what you see. What do you see here? Multiplication, and then we also see power, okay? And so if we see multiplication, that means we can expand it out with addition. So it's going to be log base A of X to the third plus log base A of Y to the second plus log base A of z. Okay, let me stop there and make sure you're with me. Make sense? Jack, you okay? Okay. All right, so now what you should see is we have the power rule. And so the power rule says that if I have an exponent, I can move it in front of my log. So now I would have 3 log base a of x plus 2 log base a of y, and there's no exponent here. So plus log base a of z. And that's my answer. Okay. All right, what about B? Okay, what do you recognize? Good. Have a bar, so that does mean division. What else? Good, so that's going to be your power property. And then one more thing. So that's multiplication, right? Okay. All right, so let's do it. So the first thing we're going to do is take care of this division. And so we're going to get log of 5a. Division expands out into subtraction. So minus log of, oops, let's do it this way. Minus log of 4b squared. Okay, that's my first step. Good. Okay. Now, let's go ahead and take care of this multiplication. This is multiplication, so that means I can expand it out into addition. So it becomes log 5 plus log a. Make sense? Minus what? Oh, you jumping ahead. Let's hold off on that 2 for the moment. This is multiplication, right? So that means I can expand it out by saying minus log 4. Okay, so generally it would be plus because you're right. We expand this out into addition. But because all of this was on the bottom, it's like you're distributing that negative. So that positive that would normally be there is going to become minus log b squared. Okay. And then our final step is what you recognize as that 2. So that means it simply moves to the front. So our final answer is log 5 plus log a minus log 4 minus 2 log b. Questions? Pretty simple? Okay. All right, let's look at C. So C is the natural log of the cube root of 5x to the 5th. Okay. All right, so this one's a little different simply because we have a radical, but we know how to rewrite that radical. We know if we have the square root of x, that's the same as saying x to the 1/2 power, correct? And so if we have the cube root of x, that's the same as saying x to the 1/3 power. So I can rewrite this as the natural log of 5x to the 5th power, all to the 1/3 power. All I did was change my radical, my cube root radical, into a rational exponent. Okay. All right, now we have that power. So what can we do with the power? Very good. So this is going to become 1/3 the natural log of 5x to the 5th power. Okay, what do you recognize now? It has an exponent, and we also see what? Five times x means that that's what? Multiplication, so we expand it out into addition. So we get 1/3 times the natural log of 5 plus, good, natural log of, good. Are we done? Perfect. So 1/3 times the natural log, and actually, let me go back here. I didn't put my parentheses because everything was to the 1/3 power, okay? So when I expand it out, I have to keep it that way. So now this becomes 1/3 times the natural log of 5 plus, move that 5 in front. So 5 times the natural log of x. Okay. You can leave it like this, or you can distribute that 1/3 in. And so more simplified would be 1/3 times the natural log of 5 plus 1/3 times 5 is 5/3 times the natural log of x. Questions? Okay, you okay, Bryce? Okay. All right, D is log base A of the square root of A to the 6th, B to the 8th, all over A squared, B to the 5th. Okay, what is the first thing you think we should do? Very good. So this is going to become log base A of A to the 6th, B to the 8th, over A squared, B to the 5th, all to the 1/2 power. Okay. Now, up here, we moved the exponent or the power to the front. We could have gone ahead and made it 5 to the 1/3 and x to the 5/3, but we ended up doing it at the end. Now, we have a lot of exponents going on here. So what I'm going to do is just go ahead and multiply them in, because remember we have a power rule of exponents that says if we have a power on the outside, we can distribute it to our exponents on the inside. Okay. All right. And so this will become log base A of 6 times 1/2 is A to the 3rd power. B, so 8 times 1/2 is 4. Good. So B to the 4th over A to the 1st, B to the 5/2 power. Okay. All right. Now, what do you think we should do?
Could you divide the A's and B's next and then subtract the exponents?
We could, however, so if this was not, generally what we do is we just expand from here. Yeah, we just want to expand from here. I like how you're using your properties of exponents, but we want to expand from here because we're taking the log of this. And so if we expand, we want to be able to condense it back. Okay, and so if we subtract these, then we wouldn't end up with the same thing we had. Okay. All right, so from here, we are going to subtract because we see division. Okay, so we have log base A of A to the third, B to the fourth. I didn't touch that yet. Minus, and remember, I'm putting this in parentheses because all of this is on the bottom. So minus AB to the 5/2 power. Okay. Now, what do you think we should do? Good.
So it'd be log base A
Mhm.
plus A cubed. I mean A cubed.
Okay, so log base A of A cubed. Okay,
Plus log base A.
good. So we saw multiplication, we expanded it out with addition. Okay, what about over here?
And we subtract log base A.
And I just realized I left my log out. So this should actually be minus log of A B to the 5/2 power. Okay, I left that out up here, but yes, you are correct. So then this becomes minus log A.
Minus log base A.
Mhm.
of
Good. So minus log base A of A minus log base A of B to the 5/2 power. Questions so far? Good. Mac, you okay back there? Okay. All right. What's last? Excellent. So we have a log, 3 log of base A of A plus what?
log base A. I mean 4 log base A to B.
Good. 4 log base A of B.
Minus
Mhm,
log base A of A.
mhm.
Minus 5/2 log base A.
Good. That's our final answer. Questions? Okay. All right, so we've been expanding. We can also condense. So if you look here, you'll see that we have a log with every expression. So here we do what's called condensing. And when we condense, we are going to write it with just one log, okay? So A says, express it as a single logarithm. So what you want to do is, first of all, identify what you see. So we see addition. And so when we see that, that means we can condense it into multiplication. Exactly. So one log. So log of 0.01 times 1,000. Okay. And then we can multiply this together. So what is 0.01 times 1,000? Good. So this becomes log 10. And then we can take it even a step further. what's my base that's understood to be with this log? 10. And so remember the property that says when we have the base and the expression the same, we get 1.
So
Okay.
you got the log, the whole answer is just one.
Log 10 is equal to 1 because my bases are the same. If I said log base 4, this is also 1. Log base 8 of 8, same thing. Anytime your base and the logarithm are the same, your answer is 1. Okay. All right, let's look at B. So we have the natural log of 54 minus the natural log of 6. Okay, so how can we rewrite that?
Log 54.
Good. We see subtraction, so we can condense it into division. And then what is 54 divided by 6? Good. So my final answer is the natural log of 9. Questions? All right, let's look at C. All right, so this is going to be multiple steps here. So you want to identify what you see.
Subtraction and addition.
Good. So this is going to be the quotient property. This is addition, but I also see what? Right, so this is power, okay? So what I would suggest is start out and make your way in. And so the first thing I would do is move this power. So it's going to become log base b of x to the 5th power, good, minus log base b of y, we're not touching that yet, plus log base b of z to the what? 1/4, good. Okay. All right, so now we look and we see subtraction. So that means we can rewrite this as division. And so since I'm condensing, I'm going to go ahead and put my 1 log on the outside. So it's going to be log base b of x to the 5th. Since this is subtraction, that log goes on the bottom. Oops. Of y. And then this is addition. So that means that's going to go on top with this z to the 1/4. So z to the 1/4 power. So far, so good. And then our last step, we have that rational exponent. And so that means we can write that as a radical, okay? So we have log base b of x to the 5th times the 4th root of z. The denominator is 4, so that means the 4th root over y. Questions? Okay. All right, our final example for the evening. We have the natural log of 3x plus 1 minus the natural log of 3x squared minus 5x minus 2. So again, we're condensing. And so you see 2 logs. And so when we condense those, they will be condensed into 1, exactly, as division. So we write 1 log, and then on top, we have 3x plus 1 over 3x squared minus 5x minus 2. Okay, now we're not done because we can simplify this. you should see, well, something should go off in your head that, okay, this is a quadratic, so I might be able to factor it and simplify out. So let's try that. So we can make our T-chart here. Can't simplify anything on top just yet. So remember, we do A times C. So that's 3 times -2, which is what? -6. Okay, what goes here? All right. So I need two numbers that multiply together to get -6, add together to get -5. About 1 and -6. Okay, so 1 times -6 is -6. 1 plus -6 gives us our -5. And so then we take those two factors and put it with our 3x squared. So we get 3x plus 1 times 3x minus 6. And then our last step is to what? Divide by the GCF. Okay, so this one is 1 and this one is 3. So our factored form is 3x plus 1 times x minus 2. So we're going to take this and replace it over here. So we have the natural log of 3x plus 1 over 3x plus 1 times x minus 2. Okay, can I simplify anything? Good. So my final answer is the natural log of 1 over x minus 2. Okay. All right, so at the very bottom, you will see a summary chart of all the properties that we've looked at this week. We have the product rule that says if we have a log with a base and we're multiplying, we can expand out into addition. We have the power rule. The power rule says if we're taking the log of something and it has an exponent, we can move that exponent to the front. Okay. Quotient rule says if we're taking the log and we're dividing, we can expand out using subtraction. Change base formula says that if we have a log with a base, then we can change this into base on the bottom. So log base A of m, and that's just log. Okay, so that's your common log. So log m over log b. Just remember base on the bottom. And then the last properties that we've looked at, we have, remember when our base and our logarithm are the same. So log base A of A equals 1. Base and base equals the exponent. So when our bases are the same, our answer is our exponent. Anytime we take the log of 1, we'll get 0. Doesn't matter what the base is. And then lastly, when we have a base and base again that are the same. So A to the power of log base A of x, then our answer is that logarithm. Okay. Any questions for me? No? Okay.